Is bonnet selection so simple that for high temperature we take extended bonnet, for low temperature we take cryogenic service, and for fugitive emission service we take bellow seal? The answer is no, it is not that simple. Bellow selection requires a lot of engineering judgment. But before that, what is the basic criteria? The first thing we need to know is the end connection of the bonnet, and the second thing we need to know is the what is the body design of the bonnet required. And then you also need to know the material selection, which is a very important part which we will cover in this video. The first thing to note is what is the bonnet in and of itself. If you see this, let us imagine this to be the valve body and the actuator which comes on top. So what is in the middle available is the bonnet, which connects basically the valve body to the actuator. So this part which you see here is the bonnet of the valve. How is the bonnet connected to the body? There are three viable options available. One is threaded option, bolted option, welded option. What do you think out of the three is the most used option? The answer is a bolted design is preferred. Why? As an engineer, we must question this. The reason for that being are many. Let us look into the key parameters. One thing is the threaded connection is generally not recommended when you have a pressure component. So this is a pressure retaining component. The valve's pressure of the fluid is going to be exerted to the bonnet. So we want it to be strong connection. Then why not go for a welded design? Welded design is very good, but it reduces flexibility. If you want to do valve maintenance, if you want to open the packing, if you want to change the packing, if you want to increase the torque of the packing, so basically you reduce your flexibility. So the middle option available, which is the most used design, is the bolted design, which is the most preferred, especially for globe valves. See, what about rotary valves? Rotary valves don't have that kind of bonnet, right? If you see here, this small section here is what we can term as the bonnet for rotary valve design. It is generally what valve manufacturers call it an integral part of the design or integral to the valve body. So here, this is the bonnet that is available for a rotary valve design. We had learned up till now, let us summarize quickly, is there are two types of bonnet selection methodology. The first is by end connection. End connection can be divided into four types, which is the threaded connection, bolted connection, welded connection, and the integral design. Now we will look at the interesting part of the video, which is bonnet selection based on the body type. First thing to notice, if you see here, this is a temperature analysis of how a valve experiences the process temperature. If you see here, the highest temperature is felt where the body of the valve is actually in contact with the surface. But if you see on top, there is a temperature effect. Do you see that? That means the temperature will be translated to up till the actuator. So we need to control this temperature from harming our electronics, packing, and also the material must be able to withstand this. If you see here, for any valve, let us try to have an hypothetical example of temperature dissipation. So if you see here, let us say at the body of the valve the temperature is 300 degrees Celsius. So eventually up till your actuator there has to be some temperature dissipation. So if we mark this on the graph, we see around 200 degrees Celsius. Now if we put an extended bonnet, what is going to happen? An extended design, this is basically your extended part of the bonnet which we consider. So if we do a temperature graph of this, what we see is at the end point the temperature is dissipated and it is just 100 degrees Celsius. So higher the bonnet extension, the higher is the temperature dissipation. This phenomenon is very important for us. The first thumb rule to be considered is that for around 200 degrees Celsius, we can go for a normal design. If the temperature is up till 400 to 600 degrees Celsius, you can go for an extended design in order to dissipate the temperature. But this has to be consulted from the valve manufacturer. Also, is this the only criteria to be considered? The answer is no. There are more important criteria with respect to high temperature services. Let us take an example of what happened in 1986. Here, NASA wanted to launch its space shuttle Challenger, and the space shuttle was very well launched, and just 10 seconds in the air there was a big blast and the entire rocket was into pieces. Yes. Why did this happen? One of the criteria what happened was, imagine here is the gasket and here is the engine metal wall. Now at such high temperatures the engine wall would expand due to thermal expansion, and the gaskets were at very low temperature before the launch, so they could not seal at time, and the flammable gas released outside and that was sufficient to ignite and the entire rocket was completely into pieces. This is very important for engineers to know. Why? Because different materials expand at different rate. For example, expansion of Teflon is 10 times that of steel. So different materials will expand at different rate. This is important especially because that particular gasket material which was used in those space challengers is also used in our oil and gas industry, which is FKM Vuitton. And these gaskets before the launch were actually covered in snow because the rocket itself before the launch had snowing, and thus it could not expand at the right time and save the gases from coming out from the engine. Now this is very important for us to know. When you see about here, when it is high temperature, you need to know two important things. First is the packing material should be able to withstand the temperature. So generally the packing materials which are used are PTFE or graphite. PTFE generally has a recommendation up till 200 degrees Celsius. So if the temperature dissipation cannot go and dissipate less than 200, then you might have to go for graphite for those options. The second important criteria is the material of the bonnet itself. Maybe carbon steel might not be sufficient and you might have to go for high temperature carbon steel or SS304316L for these cases depending on your process liquid. This is the fin design available here. In the fin design is basically used in legacy projects generally, where fin design helps to have further temperature dissipation. In this design, one important thing to be considered is about insulation. If you insulate the fins itself in any plant, this will defeat the purpose. The purpose of the fin is to basically dissipate the temperature outside to atmosphere, and thus we need to keep the fin uncovered. If we cover the fin, then this defeats the engineering purpose of why a fin design was used. Let's get to cryogenic service. For cryogenic service, if the temperature is 0 degrees Celsius, can we call it cryogenic service? Obviously, right? No. Cryogenic services have a temperature which should be very less. So for example, for cryogenic service, there's a lot of debate, but let us go with Bella Liptak's option. So let us say around 101 degrees Celsius can be considered to be cryogenic services. In cryogenic services, one important thing to be considered is orientation. Should the orientation be on top or should it be on bottom? And is it really required? By the end of the video, you will yourself be able to give the answer to this question. The first thing to note is a simple law of physics. The molecules of the gas are further apart from each other. The molecules come a bit close when it is a liquid service or a liquid structure, and it's solid, the molecules are very much close to each other. This concept is very important to us. If we want to convert anything from gas to liquid, basically we need to bring the molecules together. One option is we use force. So basically we put a lot of pressure so the molecules come together, and this is the phenomenon behind compressed natural gas. If you want to convert from gases to liquid without pressure, there is another way possible. You cool the temperature so the molecules are now having less energy to move or vibrate. So basically if you cool the molecules together is where you get to cryogenic services. Cryogenic services basically exist in their natural form in gaseous state. This is important to know because this is how we will understand how a cryogenic bonnet works. So at standard temperature and pressure it would be at gaseous state. However, if you cool it down, for example LNG at minus 162 degrees Celsius, it would be in its liquid form at this extremely cold temperature. But why do we go into such cold temperatures? If you see here at 1 upon 600 times the volume has reduced, and this is very helpful to us when it comes to storage, transportation, etc. Let us see the working of the bonnet. So basically let us imagine here's a valve and here's the bonnet and here's an actuator placed onto it. The liquid is a cryogenic liquid and this is your extended bonnet. What is going to happen is the liquid is initially going to come here to the bonnet, but there is going to be temperature dissipation. And what we just learned is because there is temperature dissipation, if the cold temperature is not maintained, the liquid will finally again try to convert back into gas. And this is helpful to us. Why? Because the gas itself creates an insulation layer which further reduces the temperature to be dissipated and to come up till the actuator, which can destroy the electronics or the packing, etc. That is why if you see in a lot of references, you will always notice that the mounting orientation is very important for cryogenic services. You either need to have an upright position or you can incline it up till 45 degrees if you see from the upward position. And one thing important to notice, if you're inclining towards 45 degree, then especially additional supports might be required to support the assembly. Cryogenic service, two important things for material selection are the body and the packing. So let us look into that. What happens is at cold temperatures there is something called as glass transition temperature. That means a polymer turns from a ductile material to a hard and brittle material. That is possible. So we need to see if the packing can withstand such low temperatures. For example, what we saw in the NASA's case, FKM Vitom cannot sustain such low temperatures. Generally, PTFE might be a better choice, but that needs to be confirmed. Next thing to look into is the material for the bonnet itself. Carbon steel generally might not be a very good choice. Generally low temperature carbon steel or stainless steel is the preferred choice, but this has to be in consultation with the process fluid also. This answer should be very simple. When you have a fugitive emission service, you should go for a bellow seal valve, correct? No, this is not the correct understanding. Why? What happens is bellow seals have a lot of disadvantages. The cost is very high. You need to have high maintenance. There are accessories like pressure gauge, etc. to be put, and it cannot be used at very high pressure and temperature limitations. So when do you need to go for a bellow seal design? Bellow seal are only to be used when there is extremely low leakage requirement. What do you mean by that? Basically, for fugitive emissions, one of the world's most renowned standard has been ISO 15848. Even the TALAFT now is referring to ISO 15848 for all of its testing, etc. Now, ISO 15848 has three classes of fugitive emissions: Class A, Class B, and Class C. If you have methane as the test class, then only for Class AM, the fugitive emission criteria is 50 parts per million, which is very low, and that is very difficult to be achieved by any other means, but class B and C can be achieved by other means. For example, first we try to achieve the fugitive emission criteria with packing type. For example, V time packing. If it is not able to sustain, then we try to go for live load packing, which can again try to have lower fugitive emissions. If the criteria is very stringent like 50 ppm, then only we try to go for a bellow seal design. Now in terms of bonnet selection, we learned two important criteria, which was end connection and the bonnet body design. In end connection, we learnt about what is threaded type, bolted type, and welded type, and the most important or the most used one is the bolted type. And when it gets to rotary, we saw about integral design. Now if you see to bonnet body design, here you have extended design, and the legacy design is also a finned design which is available. Then you saw about cryogenic services, and then you saw about when to use bellow seals. We have also introduced advanced instrumentation group on WhatsApp. So basically every month you can learn to have monthly Q&A sessions of engineers around the world, what the questions they have and the answers to it. The second is you get the videos directly on WhatsApp. I've not monetized my channel, so I directly send, so you get videos without any distraction. The best thing is, the reason for so many years to not start this channel was privacy. So now WhatsApp has a new feature, so even if we have 1,000 members coming in, the privacy of each person and their number is secured. If you want to join the group, the link is given in the description below.